let's take a look at the questions on homework number 16. The first topic is reviewing transforming formulas. In this question, you're asked to solve the formula for the letter F in terms of t. That means we need to get the letter F by itself, and we need to get t on the other side of the equal sign. So let's get started by first realizing that the variable that you're trying to isolate cannot be in the denominator. So to clear that from the denominator, we're going to multiply both sides by f, giving us t times f is equal to 1, and now we can isolate the letter f by dividing both sides by t. The final answer is f is equal to 1 over t. So we're going to insert that into the answer key here. They already typed the f equals, so we simply have to type the 1 over t. Let's try a next question. This one asked us to solve the interest formula I equals PRT for the letter t in terms of p, I, and r. Okay, so let's take a look here. Remember, when you have multiple things that are multiplying here, you can divide by them at the same time. So if we want to keep t, that means we want to divide by both p and r, giving us I over pr is equal to t. Let's take a look at one more. In this example, we want to rewrite the formula to isolate the term b1. And in order to do that, I'm first going to clear this fraction 1/2 that's outside the parentheses here, timesing this entire quantity. So I'm going to multiply both sides of this equation by the reciprocal, or 2 over 1. So I'm going to just go write it 2, and that gives me 2a is equal to h times the quantity b1 plus b2. Let's clear this h by dividing first, leaving us with 2a over h equals b1 plus b2. Notice I removed the parentheses because there's no longer an h to be distributed. The final math move here would be to subtract b2 from both sides, and that means that the 2a over h is going to be first, and then the subtract b sub 2 is going to be last. So when you're typing that here in the answer box, you can use the division key to get the fraction, and then to type b sub 2, you simply click this button here. Alright, let's take a look at the second topic. Second topic is strength of linear relationships. So this one is talking about the regression equations. Remember, for regression to be strong, it needs to be close to the value of 1 or negative 1. And so this one is looking for the weakest linear relationship. The weakest linear relationship of these three numbers would be the number that's closer to 0. Closer to 0. So that would be this one here, regression 3, because it's only 0.23. Whether it's negative or positive doesn't matter. The closer you are to 0, the weaker you are. This one is asking for the strongest linear relationship. So strongest is closest to a 1, either a negative 1 or a positive 1, but you can never be over or past that number. So this one is not even possible. So the number that is closest to 1 is 0.76, so that's regression equation 2. Alright, let's take a look at the third topic here, interpreting box plots. Each question will be different. This one happens to ask us about the range of the data, but they could also ask us about the median, the interquartile range, percentages, mins, and maxes. So the range is the distance from your minimum value to your maximum value, and so you'll need to look downwards at the scale here to see what those numbers are, and also to see what the scale is. So there's 1, 2, 3, 4, 5 sections here from 0 to 20. So 5 sections from 0 to 20 would make them 4 units each. So 4, 8, this would be 84, 88, 92, 96. So 96 and 8, and we subtract that there, and we get a span of 88 units. So the range here would be 88 units. Let's take a look at the next question here, which is asking us about the lower quartile, also known as the Q1. The Q1 is the leftmost side of the box. So take a look here at the scale. It looks as though we have 1, 2, 3, 4, 5 units, and it moves 5, so each unit would be 1. So this one here would be 62. The next question is about the median. Remember, the median is the line inside the box. It's not always necessarily in the center, but it is inside the interquartile range here. So the median is this data value here. Looks like we are going by tens. So 50, 60, 70, 80, 90. 90 would be our response. Okay, let's take a look at the next topic. The next topic is on evaluating piecewise functions. So we have two sections of graph here. We have a quadratic and a single point. Let's see. When I scroll down here for the question, it asks us to find the value of the function when x is 0. So when x is 0, that would be here on the x-axis at the 0 point, we need to find our graph. So we need to look down or up, and it looks like the graph is going to be up right here. So this is the output value. This is what they're looking for. So the answer is when x is 0, y is 8, or the function is equal to 8. So I'm going to scroll down and type that here. Again, one more time, when you are given a function and you are asked to find a specific value, this is the x-coordinate, so we go over to the x-coordinate of 6 and we go find our graph. Our graph happens to be located again at the number 8, so I'm going to type that here into the answer box. And let's take a look at the next question, see if we get something a little bit different this time. Alright, this one asks us to find f of 3. So here I go, f of 3. When I slide up here, or even when I slide up here, I get two intersections. They're both open circles. And when you have an open circle, that means that you are not equal to that value. So there are no values when x is 3 that are equal on this graph. So we're going to say, this button down here, that it's undefined. One last question. Find f of 0. So when I scan here 0, I touch here, and I also touch that single point there. This one is not a value. This one is a value. So it looks like we're going to type 6. Alright, let's take a look at the next topic. Evaluating piecewise functions without a graph. So this one is algebraically. So when you're looking at the input of 4, you have to check carefully at the domain restrictions over here. Which function should you be evaluated for? So this one says you have to be less than 1, but greater than -4, and 4 is greater than 1. So this function is out. And this one says, yes, you can come into this function if you are equal to 4. So this is the function we're going to use. This is the letter we're going to erase and replace. And this is the input, 4. So we're going to compute. 3 times 4 is 12. 12 minus 10 is 2. Next question. All right, we've got 3 functions in our pieces this time. 1, 2, 3. We've got the restrictions on the domain here, and we want to find the function output when the input is -2. Well, this one says you have to be less than -2, so that's out. This one says you can be -2 all the way up to 3, so this seems like what we will need to be evaluated. So I'm going to erase and replace. I'm going to insert my input of -2, and then I'm going to compute. The opposite of -2 is 2. 2 minus 1 is 1. And that's what I'm going to type here. All right, one more time. Make sure you're using the correct function for your input. This input is 7, and 7 is not less than 1. It's not equal to -1, and it's definitely not in between -1 and 2. So it doesn't fit into any of these categories. Therefore, it's undefined. All right, let's take a look at the last topic. On this one, you are given two graphs of f of x and g of x, and you are asked to find the solutions to f of x equals g of x. So a solution is any intersection point. And for us, that intersection point is only one time, and it's at the point 1, 5. So they want to know, what is the x value of that point of intersection? So if the point of intersection was 1, 5, then the x values only for this is 1. So we're going to type a 1 in here, and that's it. Let's try one more time. Here are our two function equations, right up here. Here are our two function graphs right here. And all we're looking for is how many points of intersection that they have. So it looks like they only have this one point of intersection. It is the point 6, 2, but they only want to know what the x values, right? When this is the statement, they want to know for what value of x will the two outputs be equal. So for what value of x? So for us, it's a 6. So we'll type that here because there's only one solution, so we don't need to click this add solution here. All right, got a next question here. We've got a square root function and a linear function. It happens to have one intersection at 6, 6. The x value is 6. Let's see if I can't get a question here where there's more than one output. Okay, I skipped ahead to a different question. And in this graph, there's more than one solution. Looks like we have a solution here and there. And those points of intersection are -2, 0, and 3, 5. And again, when they want to know when is f of x equal to g of x, they're looking only for the inputs. What are the x coordinates when these graphs intersect? So we have two answers this time, -2 and 3. And so when I scroll down to enter my solutions, I'm going to click this button here, Add Solution. And that's how I can input more than one point of intersection. All right, that's it for homework number 16. Good luck.